Science Beetle.
Hey, welcome back, students. In this video, I want to go ahead and continue the conversation around stoichiometry and identifying the limiting reactants. Here on the screen, you see all the work that we did in the previous video. So if you watched that video, this is how we got to the answer. We had determined that the chlorine was the limiting reactant. We had started with moles. However, in this particular video, what I want to do is kind of show you a different way of solving this problem, but we're going to use mass as a way of solving. So let me go ahead and erase some of the information that we've got here, modify the problem, and then start again. What I'm going to do is I'm going to change the unit of moles. Up here, I'm going to change this to grams, just so that you're aware. So let me go ahead and do that, and I'll come right back. All right, so here is the updated problem. You can see that I've changed the unit. Now the unit are grams. We still have the same problem. We still got 2.5, but now the units are grams. And we still have to identify what the limiting reactant is of the same reaction. So here's the format that we're going to use. Since this is a limiting reactant problem, what we need to actually try to do here is we need to make sure that we can identify which of these two reactants is going to run out first. Now, normally I would say you want to use stoichiometry for this process all the way through, which means that you're going to have to do a process of converting from grams of the given amount. Convert this to moles, and then you're going to convert moles of the given, and then you're going to convert this to moles of the target compound, which is going to be the one you don't think is the limiting, and then you're going to have to convert this to grams of the target. Now you can see here that there's a number of steps here. There's a 1 conversion, 2 conversions, 3-step conversions in order to get the answer. The method that I want to show you in this case is looking at a mass relationship between the two compounds. So let me show you what that means. I'm going to put the format here on the screen. So what we want to do here is we want to take these compounds, and let me go ahead and zoom in. And all we really want to do here is take these independently. So I'm going to color code this one green, and I'm going to color code this one yellow, because I'm going to use two different comparisons here. So for the first one here, let's make sure that we have the coefficient identified. That's a coefficient of 1. And what you want to do here is you want to take the starting amount. And so in this particular case, we know that we've got, for this compound, we've got 2.5 grams that is given. So this is going to be the amount that's at the start, what's given to us. And then we're going to divide this amount by the molar mass. Now what this is going to give us is going to be the number of moles of this particular compound. Since we're dealing with CS2, this is going to give us the number of moles of CS2. This is only part of the information. The next thing that you want to do at this point is you want to go ahead and divide by the coefficient. So I'll put this in, I guess in purple. You want to go ahead and then divide this by the coefficient for that one. So it would be coefficient 1. This ultimately is going to tell us how many total moles of CS2 we have in this reaction. Now we go ahead and do the same thing here for the other one. Let me go and switch colors. So we'll do the other compound over here. We're going to take the starting amount, 2.5 grams. In this case, it'll be CO2, and we're going to divide this by the molar mass of CO2. That'll give us a number. Whatever that number is, we want to go ahead and divide that by the coefficient. So in this particular case, the coefficient is going to be 3. So here I would divide the final answer here by 3. And then what we're going to do is we're going to compare this value, whatever it is, compare it to the value over here. Whichever is the smaller number is the limiting reactant. So that's the concept. Let's kind of go through this, and so you can see the numbers for yourself. Let's begin by clearing out the stage here, and then I'll just show all the work. All right, so we'll begin here with this one. So we're going to start with the CS2. So we've got 2.5 grams of CS2. We're going to divide that by the molar mass of CS2. And so in this particular case, we had already done a little bit of the work before. Sulfur is 32. And so let me zoom out a little bit here and then give us a little bit more space here at the bottom. And so CS2 has a molar mass of 12 plus 32 times 2. This will give us 64 plus the 12. So if we add all these up, we're looking at 76 grams per mole. And so here what's going to happen is, notice the units of grams cancel, and what is left is the moles. So if we do this math, this is going to give us the following value here. So I'm just going to go ahead and take the calculator over here off screen, take the 2.5 divided by the 76. That's going to give us a value of 0.032 moles of CS2. Now I'm going to take this number and I'm going to divide it by the coefficient. In this particular case, the coefficient is 1. So I'm going to wind up getting the same answer. Okay? So in this particular case, I'm going to wind up getting 0.032 moles, or overall, that I have of the CS2. So this is an important value. So I'm going to put that in squares. Let's go ahead and clear off some space down here at the bottom, and then we'll do the work for the other compound. And so in this particular case, we're going to take the 2.5 grams, this case is Cl2. I'm going to divide it by the molar mass of 2 chlorines. Chlorine itself is 35.453. So if I take that number, 35.453, for 2 of them, the overall molar mass here is going to be 70.906. Now, you could round this to 71. This will be grams per mole. And what you're going to find here is the grams is going to cancel with the grams, leaving you the unit of moles. And in this particular case, if I take that 2.5 and I divide it by the 70.906, that's going to wind up giving me a value of 0.035 moles of Cl2. Now I do need to divide this by the coefficient for the chlorine. In this case, it'll be a 3, so I'll put a 3 down here at the denominator and carry that math out. So I'll take that number that I got before, divided by 3, and then the number that I get here is 0.011. Now, these are the two values I'm going to compare. Which is smaller, 0.032 or 0.011? So if I actually put these side by side, you're going to find out here, let's just put it side by side over here on the left-hand side. We'll put 0. Let's use a different font. Let's use the 0.032 versus 0.011. So clearly the 0.032, this is actually bigger. And so the number over here on the right-hand side, this is actually smaller. And so the one that's the limiting reactant is the smaller number. So smaller, therefore, this is limiting. And so which is the one that's limiting? Limiting is the one here. For this value, it corresponds to the Cl2. So the limiting compound here, or the reactant, is Cl2. Cl2 is the limiting reactant. And so that's the way you would solve this particular problem using this particular method. So here's the entire workup for you to look at. Again, just to recap, take the starting amount, divide it by the molar mass, and then divide it by the coefficient. That'll tell you the number of moles of that specific compound overall. Do the same thing for the other compound. Compare the two values, the values in purple. The smaller one is the limiting reactant. So for our particular problem, 0.011 is the smaller one. That corresponds to Cl2, so the Cl2 is limiting. Now, if you're looking at the shortcut that I had shared before, remember I had said the reactant with the larger coefficient typically is the limiting reactant. So in this particular case, we identified as chlorine as the limiting reactant, and looky, here we've got 3 as the coefficient. 3 is greater than 1, so the limiting reactant is chlorine. So that's the way you solve this one. Check us in the next video where we'll look at some more sample problems like this. Until then, keep watching, keep learning, and we'll see you in the next video.